Hello everybody, this is Matt from Megalomobile and welcome to part 2 of this mini-series Let's Make Solitaire in Unity. In part 1 we set up the scene, generated a deck of cards, shuffled them, and printed the results out to the console. If you missed episode 1, I'd recommend checking that out first as we will pick up right where we left off. In this video we will assign sprites to the cards, sort the cards into their correct piles, and deal them out to the Tableau, which, as I'm not sure I can pronounce correctly, we'll just call the bottom row. As usual, all the scripts and Unity packages are available in the description, and the most recent version can be played in a browser. Let's crack on. Now that we can create a list of card names and shuffle it, we can use that list to create cards that we can see on the screen. As we know, the order of an unshuffled deck will always be the same, alphabetically, arranged by suit and value. We can use an array of sprites in the same order to make sure we always show the correct card. Public sprite array card faces. Back in the editor, we can select the Solitaire script, expand the card faces, and give the array 52 locations. We can then go through and attach the correct sprite to each spot. This is a little mind-numbing, but it only needs to be done once. We can also take the opportunity to tidy up a bit. I've created a new folder for the scripts and a new folder that will house any prefabs created. As we are spawning multiple copies of the card, it will need to be a prefab, so we can drag it in there. The Solitaire script will handle dealing the cards, so we create a new public game object, the card prefab, and attach the card prefab we just created to the script in the editor. Next, we need a method to deal the cards. Void solitaire deal. For each string, card, in deck, we instantiate a new card prefab. As this is just going to be a quick test, we can spawn them at the transform position of this game object, which, as we reset the transform, will just be the center of the screen, and quaternion.identity, which matches the rotation. The name of the new card game object created is going to be the string of the card name, so new card.name equals card. The solitaire deal method is then added to the play cards method. Save and hit play, and it looks like a single card has appeared on the screen. However, if we take a look at the hierarchy, we can see that there are 52 individually named and shuffled cards here. They just all share the same position and currently only display the cards back. To get a better visual representation of the cards, we can give them an offset in the Y and Z axis. In the solitaire deal method, we create a float Y offset, which we can start equal to 0, and a float Z offset, which we can start equal to 0.3 float. Then we can amend the instantiate position to be a new vector 3 and build it from a transform.position x, y, and z of the game object. We can then subtract the appropriate offset from the z and y values and, on each iteration through the loop which instantiates the objects, increase the offsets. I'll increase the y offset by 0.1 float to start with, and the z offset by 0.03 float. Now, saving and heading back to the Unity editor, we can see that all 52 cards are now spawned in a single row. Entering 3D mode, we can see that the lower a card is, the closer it is to the camera. This can help with rendering issues and hit detection. Now that we have cards on the screen, we can update the sprites to match the cards to their names. We already created an update sprite script and attached it to our card, so within the update sprite script, we can handle the sprite swaps. We create public sprite card face, public sprite card back, and attach the back of the card to the card back slot in the editor. I want interactive objects to have a unifying script that looks after things like their values to help keep track of the gameplay. So I'm going to add a new script, selectable, to the card prefab. Within the selectable script, we can create a new public bool, face up, and set it to be equal false at the start. Back within the update script, we need access to the sprite renderer, the selectable script that we just added, and the solitaire script, as that is where we added the sprite array that houses all the card faces. Private sprite renderer, private selectable, and private solitaire. To assign the correct face card for newly instantiated cards, we can use the arrays created in the solitaire script. I have named the instance of the card prefab based on the string from the deck, and also added the card faces in order of an empty deck. Therefore, the list location where the name of the card matches the string in an empty deck is the same number as the location of the correct sprite in the sprite array. As the generate deck method is inside the solitaire script, we can just call it to build a quick empty deck to test against. In the start method, we can add list of type string deck equals solitaire.generateDeck. We also need access to the sprites, so we can create a quick variable to help with that. Solitaire equals find object of type solitaire. Now we can build a loop that matches the name of the card with the strings in the deck. Int I equals 0 for each string card in deck. If this.name is equal to card, cardface equals solitaire.cardfaces at location I. Break. We don't need to keep going here as we found the correct card already. Then we increment I. Sprite renderer equals getComponent sprite renderer, selectable equals get components selectable. Then in the update method, we can say that if the card is face up in the selectable script, then to show the card's face, otherwise show the card's back. If selectable.faceUp is equal to true, sprite renderer.sprite equals card face. Else sprite renderer.sprite equals card back. Back to the Solitaire script, and we can add a line that makes any dealt card face up for the time being. New card.getComponent selectable.faceUp equals true. We can also increase the Y offset to allow us to see more of the card faces. Save the scripts and remember to update the prefab. When we play in the editor, we can see that all 52 cards are shuffled and dealt with the correct faces. They fall off the bottom of the screen, but we can head back over to the scene panel to take a better look at our creation. Selecting a card and toggling the face up bool in the selectable script allows us to see that if face up is false, the back of the card will be displayed instead. Spawning all the cards in the middle of the screen isn't really part of the game, so we need a way to position them correctly when they are dealt out. To help with this, we can create some arrays to look after the positions of the empty spaces. In the Solitaire script, we can add a public game object array bottom pos and a public game object array top pos, a couple of arrays of lists to look after what is where, public list of type string array bottoms, and a public list of type string array tops, and a list of what card is currently in what position. Create a private list of type string bottom 0, and that's going to equal a new list of type string, and we do the same for bottom 1, bottom 2, bottom 3, bottom 4, bottom 5, and bottom 6. In the start method, we can build the array of lists bottoms from the lists we just made. Bottoms equals a new list of type string array, and that's going to contain bottom 0, bottom 1, bottom 2, bottom 3, bottom 4, bottom 5, and bottom 6. We are now able to sort the initial cards dealt out into their correct positions. We can do this with a new method called Solitaire sort. This method will run a couple of nested loops to put the cards in the right places. The first loop counts from 0 to 6 and saves the current count as I. Within each iteration, a second loop is run that counts from the current value of I to 6, and this saves the count as J. Within this loop, we can find the list at location J of the bottoms array and add the last string in the deck of cards. We can then remove that string from the deck as the card is no longer in it. Void Solitaire sort for int I equals 0, while I is less than 7, increment I. For int j equals I, while j is less than 7, increment j. Bottoms at location j dot add deck dot last of type string. The dot last functionality for finding the last entry in the list is not a standard function. To be able to use it, we do need to add an additional library using system.link. Then we can say deck.remove at deck.count -1. So, when I is 0, 7 cards are added to the bottoms list, 1 at each location. But the second time through, J starts counting at 1, so location 0 is skipped over. This repeats, adding 1 less card to each row until all 7 rows are complete. Heading back over to the editor, we can connect the bottom pos and top pos arrays with the appropriate game objects. Top pos has a size of 4, and we can just drag and drop the respective game objects. Bottom pos has a size of 7, and we can do the same. Back in the Solitaire script, instead of dealing the cards all in the same place, we can use the positions of the game objects we've just added and the contents of the bottoms array of lists of strings to populate the playfield correctly. Within the Solitaire deal method, we can create a new loop that counts from 0 to 6 inclusive. For int I equals 0, while I is less than 7, increment I. We can then change the instantiation position to instead be the bottom position at the location of the count. Bottom pos at location I dot transform dot position dot x, and we do the same for y, and we do the same for z. The instantiated cards should also be children of the game objects they're being dealt on top of, so we can add an extra argument to the instantiate method, bottom pos at location I dot transform. Back in the play cards method, before dealing the cards, we call the Solitaire sort method, and as we're no longer looping through the entire deck to deal all the cards, we need to change this loop to only deal cards that are in the lists of cards at the bottoms. Save and play, and the cards have been dealt out correctly, but there is a small glitch. By setting the new cards to be children of the transforms, they inherit the properties of the parent. As the scale of the cards is 0.4, and the scale of the empty rectangles is also 0.4, the cards have been shrunk twice. Luckily, this is an easy fix. Drag the empty positions so that they are no longer children of the top and bottom game objects. All we need to do is set the scale of their parent game objects to 0.4, then drag them back over. Their size remains the same, but if we look at the individual scales, we can see that they have reverted to 1. Now we just need to update the scale of the card prefab from 0.4 to 1 and press play, and the right number of cards are dealt in the right places at the right scale. Of course, in Solitaire, only the bottom cards of each row are initially dealt face up, so heading back over to the Solitaire script within the deal function, we can add some extra logic to make this happen. Instead of making all the cards face up, we will only make them face up if the card string is equal to the last string in the current list. If card is equal to bottoms at location I, at location bottoms at location I dot count -1, new card dot get component of type selectable dot face up equals true. Now when we save and hit play in the editor, it is really starting to look like Solitaire. However, I don't like the way the cards appear all at once. I would rather that they were quickly dealt out one at a time. To do this, we can change our Solitaire deal method to be a coroutine. Replacing void with I enumerator allows us to add a yield statement to force the method to wait before completing. We can put this wait statement inside the loop to slow it down. I still want the deal to be quite fast, so I'll set the wait time between each card to only 1/10 of a second. Yield return new, wait for seconds, 0.1 float. Up in the playCards method, where we call Solitaire deal, we need to identify that we are running a coroutine by enclosing it in a start coroutine method. Now when we save and play, the cards are quickly dealt one at a time. That's it for part 2. Next time we will look at creating a way for users to click on game objects and then move on to dealing cards 3 at a time from the deck pile. Thanks for watching. If you enjoyed this video, then please hit like, please hit subscribe, and feel free to leave a message in the comments. I'll catch you next time.